Hey guys, this video is the homework assignment for Tuesday, October 15th. It is due Wednesday, October 16th. And our topic today is solving two-step equations. We spent a lot of time in the video last night talking about one-step equations, and we did tons of practice in class. So our objective is that by the time this video ends, and by the time class ends tomorrow, you can solve two-step equations by using inverse operations and undoing PEMDAS. And I like to call that SADMAP. Get it? PEMDAS backwards is SADMAP. So PEMDAS, if you don't remember, is how we figure out what operation to do first. Like if we have 3 squared minus 10 times 2, PEMDAS tells us to do parentheses first, which we don't have, then to do exponents, and then to do multiplication and division, and finally addition and subtraction. SADMAP is going to take us in the reverse order. And we're going to go through a lot of examples of how to do this today. So we're going to take a few notes on how to do this. Solving two-step equations is done using almost the same process as one step. It just gets a little bit more complicated. And you have to decide what to do first. So we're going to undo PEMDAS. We're going to do SADMAP by undoing addition and subtraction first. And when we actually get to some example problems, you're going to see what I'm talking about. This is for problems like 2x plus 4 equals 10. It's more complicated than just x minus 3 equals 7. There's two different steps we're going to have to take here, which is why it's called a two-step equation. And we're going to always undo the addition and the subtraction first, using the same method we talked about in the video from last night and in class today. After you get done fixing the addition and subtraction, you're going to undo multiplication and division. That's the next step in SADMAP. You always have to remember the rules of negatives forever and ever and ever and ever. Please be very careful. For now in class, we're not going to be dealing with any exponents or parentheses, although you can undo algebra equations that have those things. And it's kind of cool. When you get into more advanced math classes, you're going to be undoing things like 3x squared minus 4 in parentheses plus 10 equals 32. And you will actually be able to solve those equations. But don't worry, we're not doing anything like that today. We're just going to stick to plain old two-step equations. So the first one we're going to go to is 2x plus 4 equals 8. First thing I want you to do is write down SADMAP on the side of your paper, which is PEMDAS backwards, and we are going to be concentrating on the subtraction and addition first. So we don't have any subtraction in this problem, but we do have addition, this plus 4 that we need to get rid of first. I'm going to draw my little line because I always have to keep everything balanced. And I'm going to ignore right now what's happening over here in this 2x. That doesn't matter to me. I'm going to take care of that in just a minute. I'm just going to undo plus 4. The inverse operation of addition is subtraction. So I'm going to subtract 4 from the left side. I have to do it on the right side too. My 4 and my negative 4 cancel. And what am I left with on this left-hand side? I'm left with 2x. On the right-hand side, 8 minus 4 gives me positive 4, and there's an equal sign in the middle. Now, the reason this is called a two-step equation is because this was the first step. But we aren't done yet because we still don't know what x equals. We only know what 2x equals. So for the second step, I'm going to do this whole balance thing. Again, this is the second step. And now I'm going to get rid of my division and multiplication. There's no division in this problem, but remember, a number right next to a variable is hidden multiplication. Mathematicians are lazy and they don't feel like writing the multiplication. So in order to undo this multiplication, I have to do division. I have to divide by 2. Divide both sides by 2. Over on this side, my 2 times and my divided by 2, they're going to cancel. So all I'm left with is x. That's good. That's how we want it. On the right-hand side, 4 divided by 2 gives me 2. So my answer to this is x equals 2. I'm going to write that up here, and I'm going to show you something kind of cool that you can do with two-step equations. You've written this all down, right, guys? If you haven't, pause the video and get that written down because I'm erasing it. Okay. The really nice thing about algebra is you can always find out if you solved it right before you turn your test in. You can check it. I can take this x equals 2 and plug it back into this equation. So instead of x, I'm going to put in my 2. So I have 2 times 2 instead of x plus 4, and it should equal 8. I am going to use order of operations and simplify this. 2 times 2 is 4. Bring down the plus 4, and it should equal 8. 4 plus 4 is 8, and look at that. 8 equals 8. That's what I'm looking for. That's my checking step. If I were to end up with like 16 equals 8, I've done something wrong. So I need to go back and resolve it, or maybe I did something wrong in the checking step. And yes, guys, I expect to see this checking step when you are taking a quiz or a test or something like that. And you're going to get really annoyed with me because I'm not going to let you turn anything in until you show me that checking step. Let's work through another example. Okay, this time we have negatives that we're going to be dealing with. So we, of course, have to remember our rules of negatives. I'm going to write SADMEP down on the side. SADMEP. I'm going to draw my little balance. And my first step is to get rid of the subtraction and addition. I have minus 7 here. I'm going to change that to plus 7. Plus 7. Those cancel over on the left-hand side, leaving me with 6x equals, and then I have to do negative 19 plus 7. Here's where the rules of integers come in. And I suggest you do some scratch work over on the side. Don't try and do it right here. It's going to get too confusing. But over on the side of your paper, you can use any of our methods for adding and subtracting integers. I'm going to use additive inverses and split this up into negative 7 and negative 12. My 7 and my negative 7 are going to cancel, and I'm left with negative 12 over here on the side. But I'm not done yet. I have to do my second balance, my second step, and I have a 6 right next to an x here. That means they're multiplying. So in order to undo that, I divide both sides by 6. Over here, my 6 cancels, leaving me with plain old x, and negative 12 divided by 6 gives me negative 2, because a negative divided by a positive is a negative, and 12 divided by 6 is 2. So now I'm going to write over here on the side x equals negative 2, but I'm not just going to say, yay, I'm done. I'm going to check it. So over here, I'm going to erase all of this work. If you didn't get it written down, rewind and pause the video. And I'm going to substitute negative 2 in for x and see if I get negative 19. So I have 6 times negative 2 minus 7 equals negative 19. Following order of operations, I do 6 times negative 2 first, which should give me negative 12 minus 7 equals negative 19. I'm going to turn this subtraction into adding the opposite. So I have negative 12 plus negative 7. And yeah, that does equal negative 19. Yay, I'm so happy. It works. Negative 2 is the answer for x. All right, so I am going to give you, I'm going to give you this as your reflection question, and I'm going to give you the hint. Remember that a fraction bar is division. Okay, so think about what you have to do to undo division. And don't forget that I want you doing SADMEP. So you're going to undo subtraction and addition first, and then you'll undo division and multiplication. So write your answer for what you think M equals in Edmodo when you turn in your reflection. And I can't wait to see what you guys come up with. Have a great evening. Bye-bye.